Welcome to part 6 of deploying Kubernetes-based distributed systems. This video will talk about debugging techniques, focusing on open source and free tools. The illustrated principles should be helpful independently of the tools. Let's start with the most common problems related to the creation of resources. Confirm you have the requirements set. For cloud providers, check authentication and quotas. Some cloud providers will time out your authentication after a given period. Each cloud has different mechanisms to authorize users to create or use resources. Avoid risky collisions with other users, mainly for globally unique items in some cloud providers. Using some random value as part of resource names helps to avoid naming collisions. Creating or clearing resources may take time, mainly for cloud environments. On rare occasions, commands may return while resources aren't ready, requiring manual fixes. Debugging the issues related to creating components may also be time-consuming. It is crucial to verify used versions for tools, baseline images, compilers, and even code. Building components may require connectivity to services, like Docker or registries. Tools or baseline images retrieved from the internet may cause transient errors. During development, containers may be instrumented with additional tools. After system integration tests, removing debugging tools should optimize container size. Confirm that the latest version of the components matches what is available in the registry. Connecting the components should avoid collisions with all other services in the clusters. Development velocity will benefit from testing deployment locally before going to the cloud. The component connections will be slightly different across environments. By default, there is no load balancer in a local host, which is provided by cloud services. Pending requests for external IPs indicate a missing or wrongly configured load balancer. There are debugging flags in the Yuruna scripts for further information on deployment steps. CPU and memory requests may exhaust the available cluster resources, mainly in a local host. Another common need for experiments and enforcement is the order of workloads deployment. Components may require other resources to be ready, which may demand waiting. Components, dependencies, and Kubernetes itself may have bugs or supportability issues. Simple debugging tools, like K9s, are multi-instance and may lead directly to error issues. A cluster restart erases any state not in the images, which may require workloads redeployment. Thanks to all contributors and viewers. This concludes the series about deploying Kubernetes-based distributed systems, circa 2022.